Imagine looking up at the sky in the middle of the day and seeing colors that physics says shouldn't exist in daylight. On March 11, 2026, at exactly 12:03 p.m. Eastern Standard Time, that's exactly what happened over New York City, Toronto, and Chicago. The sky didn't just turn a shade of blue or gray, it erupted in a violent, oscillating neon green. This wasn't a reflection. It wasn't a weather anomaly. This was a full-spectrum auroral display, blazing brightly enough to be seen in broad daylight. The Space Weather Prediction Center in Boulder immediately issued a G5 geomagnetic storm warning. But here's the twist. The sun was completely quiet. No coronal mass ejections. No flares. The solar wind was sitting at a baseline 350 kilometers per second. And yet, ionization levels in the upper atmosphere shot to heights normally reserved for a Carrington-class solar event. Picture millions of people looking up at noon, witnessing curtains of light dancing against the glare of the sun. To produce an aurora that is bright in daylight requires energy flux densities 40,000 times stronger than a typical magnetic storm. That level of energy does not emerge out of nowhere. It has a source. And just 20 minutes ago, NASA's Deep Space Network confirmed exactly where it was coming from. Not the sun, not some hidden solar flare. The source, an object labeled 3I Atlas. Think about that for a moment. What we have been tracking as a comet, a ball of rock and ice, is suddenly behaving in ways no comet should. Ice and rock do not fire focused. Particle beams capable of ionizing a planet's atmosphere from 180 million kilometers away. To do this, it needs power, aim, and most importantly, intent. The telemetry from the GO-19 satellite shows that the ionization isn't covering a whole pole. It's focused a tight beam, less than 500 kilometers wide, sweeping across the eastern seaboard. Any physicist reading this should feel a chill. This isn't natural celestial mechanics. This is interaction. This is a probe. Or perhaps a test. At first, when magnetometers in Ottawa recorded a 400 nanotesla spike in just 3 seconds, scientists assumed a sensor glitch. That kind of spike should be impossible. But then the European Space Agency confirmed the same reading from their swarm constellation, 2 independent agencies, same impossible data. The atmosphere is glowing because the 3I Atlas is doing something, and the question that keeps scientists awake is not just how, it's why. Why this precise moment? Why this specific target? To grasp the magnitude of what unfolded, look at the timeline. At 11:58 a.m., the North American magnetosphere was stable. The planetary K-index, which measures magnetic disturbance, was flat 0. But 5 minutes later, at 12:03 p.m., instruments from Maine to Maryland didn't just spike, they saturated. The initial assumption at the Space Weather Prediction Center was catastrophic sensor failure. A localized geomagnetic storm of this intensity, appearing instantly without a solar flare, is scientifically impossible. Nature does not operate like a light switch. It ramps up. It gives warning signs. This event gave none. Reports from commercial pilots started pouring in. Flight 4002 out of Chicago described blinding green columns descending through cloud layers. This wasn't the soft, diffused curtain of a normal aurora. This was structured, focused. When NASA's Goddard Space Flight Center analyzed the phenomenon, they found that the ionization wasn't coming from the sun's direction at all. Instead, it traced back to a specific coordinate in the constellation focus. The geometry is staggering. The sun is in one position, yet this beam strikes Earth at an 1/8-degree offset from the solar wind vector. Tracing that vector back 180 million kilometers leads to one single point in the darkness of space. 3I Atlas. The European Space Agency's swarm satellites, which measure magnetic fields with extreme precision, detected a flux density of 3,500 nanoteslas inside the column, while just 10 kilometers away, readings were normal. A natural solar storm spreads like a shotgun blast. This, a sniper shot. A tightly collimated stream of high-energy particles targeting a specific region on Earth. Maintaining a coherent particle beam over 180 million kilometers requires technology that surpasses anything we can achieve on Earth. Magnetic containment fields, energy stabilization, natural outgassing or sublimation couldn't do this. But the beam maintained perfect cohesion, sweeping across the continent with precision. Then, at 1:15 p.m., the nature of the beam shifted. Observatories in Hawaii and radio telescopes in West Virginia detected pulsation 0.3 Hz, 1 pulse every 3.33 seconds. Pulsars spin, stars oscillate, but a comet? An inert chunk of ice? Comets do not have a heartbeat. Comets do not emit synchronized high-frequency particle bursts, targeting a specific continent on a specific planet. Data from the A spacecraft between Earth and the Sun confirmed nothing unusual in the solar wind. The energy source was local to the object, and the energy output was staggering. To ionize nitrogen and oxygen in daylight to this intensity requires roughly 400 terawatts. That's 20 times the total power consumption of all humanity. Where is a comet getting that kind of power? We are trained as scientists to search for natural explanations first. Sublimating ice, electrostatic discharges, or simple outgassing can produce energy on the scale of milliwatts or kilowatts, but never terawatts. The standard model of cometary physics simply cannot explain this. At 1:30 p.m., just before this recording, JAXA, the Japanese Space Agency, confirmed the pulsation. Their Hinode satellite picked up the same 0.3 Hz rhythm. NASA, ESA, JAXA, 3 independent agencies, different instruments, different locations, all observing the same impossible reality. We are being targeted by a high-energy beam from what should be a frozen, inert object. But energy isn't the only anomaly. The Aurora spectrum tells a story that breaks all expectations. This isn't just oxygen or nitrogen glowing in the sky. Spectral analysis reveals matter embedded in the beam. At 1:45 p.m., Keck Observatory in Hawaii turned their high-resolution shell spectrograph toward the glowing sky over North America. The results were chilling. Alongside the familiar green oxygen glow, the beam contained massive concentrations of ionized xenon, specifically isotope 129. Xenon is rare, heavy, and practically non-existent in the upper ionosphere. Yet over Toronto, its concentration was 40,000 times normal levels. Naturally occurring xenon, 129, comes from the decay of iodine, 129, linked to supernovae or the early formation of the solar system. But in high-energy physics, xenon is a propellant for ion thrusters. It's heavy, easy to ionize, and capable of producing thrust when accelerated by electric fields. If 3I Atlas were just a comet, it would be venting water vapor, carbon monoxide, maybe some dust, not projecting a coherent stream of xenon plasma across 180 million kilometers of space. This strongly suggests a propulsion system, a drive plume. And then the spectral analysis got stranger. At 1:52 p.m., the Gemini North Telescope, also in Hawaii, detected helium-3. Helium-3 is the holy grail of fusion energy, rare on Earth, more abundant on the Moon, but certainly not raining down in focused beams. The simultaneous presence of helium-3 and xenon-129 indicates a fusion reaction, an engineered propulsion system operating at power levels barely imaginable. The velocity of the particles in the beam approaches 0.04 times the speed of light, 4% of light speed. Compare this to the solar wind, moving at 400 to 800 kilometers per second. This beam is moving at roughly 12,000 kilometers per second. Accelerating particles to relativistic speeds in a focused beam requires magnetic fields in the range of 50 to 100 Tesla. The most powerful continuous magnetic field ever generated on Earth is 45 Tesla, and that required an entire building filled with cryogenic equipment. 3I Atlas is doing this in deep space. Alone, moving, that should be impossible. By 2:05 p.m., physics seemed to bend further. Algonquin Radio Observatory in Canada reported that the beam is polarized. Natural light, sunlight, starlight, even normal auroras is largely unpolarized. But the radio waves accompanying this xenon stream were 98% linearly polarized. That's the signature of a synchrotron source, meaning particles are spiraling along highly ordered magnetic field lines. Nature is messy. Space is chaotic. Maintaining 98% polarization over 1.2 astronomical units indicates an artificial emitter, a magnetic nozzle engineered to micron-level precision. Skeptics might propose a magnetar burst, but magnetars are thousands of light-years away. They blast entire systems, not select the North American continent for 4 hours of xenon bombardment. The odds that a natural event mimics an ion drive plume containing specific fusion byproducts focused into a tight beam and striking Earth with near-perfect polarization are effectively zero. Then, at 2:15 p.m., something even more telling happened. The polarization angle shifted, rotating exactly 45 degrees in 1 second. That's not random. That's a signal. Modulating polarization is how data is encoded in fiber optics every day. Suddenly, we have a beam of energy, impossible isotopes, relativistic speeds, and now a structured signal. This is no celestial coincidence. This is interaction. Either a high-energy physics experiment or a communication attempt using the planet's atmosphere as a detector. By 2:30 p.m., the beam crossed the day-night terminator line. This is where governments and observatories scrambled. The beam didn't just illuminate the sky, it started affecting matter. At 2:32 p.m., it intersected the orbit of the NOAA 2-1 weather satellite, a 2-ton spacecraft at 824 kilometers in a polar orbit. Designed to remain stable with gyroscopes and thrusters, NOAA 2-1 suddenly lurched. Telemetry from the Space Force 18th Space Defense Squadron confirmed a sudden uncommanded delta V of 4.2 meters per second. Small in everyday terms, but in orbital mechanics, enormous. It can alter inclination, disrupt imaging for days. The force vector aligned perfectly with the beam. This was not a malfunction. It was a kinetic impact from a beam 180 million kilometers away. At 2:40 p.m., the Algonquin Observatory recorded structured polarization shifts: 0 degrees, 45 degrees, 90 degrees, 45 degrees, repeating every 1.6 seconds. This is not natural. Pulsars don't oscillate polarization like that. Black holes don't. This is a carrier wave. Embedded within that wave, at 1,420 megahertz, the neutral hydrogen line exists a secondary digital modulation. NASA's Deep Space Network at Goldstone, California, locked onto it at 2:45 p.m. Preliminary decoding shows repeating blocks of 1,024 bits with error correction. This is structured information. At this moment, we have a beam of heavy ions pushing satellites, a polarized signal modulating in a perfect sine wave, and a digital transmission riding atop it. This is no comet, no natural phenomenon. This is a message, broadcast across the sky using the planet itself as a screen, and the target is us, our satellites, our technology, our ability to detect. And then, at 2:50 p.m., the beam halted. For nearly 4 hours, it swept a neon green swath from Chicago to New York. Now, it was stationary, locked onto a single coordinate in the mid-Atlantic ridge, 45 degrees north, 28 degrees west. At first glance, it was just the ocean, but geologists know this area well. It's a tectonically active rift, forming a new crust, with anomalously weak magnetic fields. If the beam's purpose were communication, it would target a city, a telescope, a satellite, not a geological fault. Unless the goal is not communication. Unless the beam is probing Earth itself. At 2:55 p.m., the nearest magnetometer at Azores Observatory maxed out, and the modulation frequency ramped up from 0.3 Hz to 1.5, then 10 Hz. The implications are staggering. A celestial object, 180 million kilometers away, can pinpoint a geological weakness on a planet and interact with it at will. This is not an observation. This is planetary-scale interaction, initiated by intelligence operating with physics far beyond our comprehension. The Aurora still glows, the beam remains locked, and whatever 3i Atlas is doing, it has only just begun. As we watch the Aurora pulse over the Atlantic, the scale of what we're witnessing becomes undeniable. We are no longer observing a distant celestial object. We are witnessing an interaction with our planet on a level that defies all known physics. The beam isn't just illuminating the ionosphere, it is manipulating it. Currents induced by the Xenon ions are coupling with the Earth itself, likely exciting piezoelectric effects in quartz-bearing rock along the rift. The implication is clear. 3i Atlas may be probing the internal structure of our planet, using the Earth itself as a sensor, a laboratory, or perhaps even a conduit. At this point, the energy readings are unprecedented. Instruments designed to measure geomagnetic activity are maxed out, yet the beam remains stable, focused, and controlled. Every fluctuation, every modulation, every pulse is deliberate. The oscillation in the polarization, now ramping up toward 10 Hz, indicates a level of precision in timing and control that is nearly inconceivable. For context, maintaining a stable particle beam of this magnitude over 180 million kilometers, modulated with digital information, and capable of exerting physical force on satellites, is not just an engineering challenge, it is an entirely new category of technology. As the beam pulses over the mid-Atlantic ridge, the potential consequences begin to crystallize. This is a tectonically active region. The energy being directed into the Earth could interact with geological faults, magma flows, or the crust's magnetic anomalies. Even minor variations in energy deposition could have far-reaching effects, from altering local geomagnetic conditions to inducing microseismic activity. It is a deliberate and measured interaction, but its full impact is something we are only beginning to comprehend. What makes this situation even more unnerving is the beam's ability to deliver kinetic energy. The NOAA 2-1 satellite incident showed that a controlled flow of particles from a distance of 180 million kilometers can physically move objects in orbit. That is not just a threat to technology, it is a demonstration of an entirely new kind of force projection. If this is a test, if this is a probe, the entity or intelligence controlling it is not limited by the constraints that govern us. They are demonstrating not just observation, but capability. The digital signal embedded in the beam adds another layer of complexity. The repeating blocks of 1024 bits, structured with error correction, suggest deliberate communication. But the medium is not radio alone, it is the atmosphere itself. Using the ionosphere as a projection screen and transmission medium is unprecedented. By modulating the polarization of a xenon ion beam, the sender can encode vast amounts of information directly into the electromagnetic environment of a planet. This is not mere transmission, it is planetary-scale messaging, potentially intended for anyone with the capability to detect, interpret, and decode it. From a scientific standpoint, everything about this event challenges our understanding. The xenon and helium, three isotopes, the relativistic particle speeds, the controlled polarization, the kinetic effects, and the digital encoding all point to a single undeniable conclusion. This is not a natural phenomenon. This is technology, and it is deliberate. 3I Atlas, previously labeled a comet, is functioning as a probe, a communication device, or perhaps a hybrid of both. The precision with which it can target a tectonic rift, modulate a signal, and exert force on orbiting satellites suggests intelligence, planning, and an understanding of physics that surpasses our own. As of the last readings, the beam remains locked on the mid-Atlantic ridge. The Aurora continues to glow in neon green, pulsing rhythmically, with each pulse carrying data encoded into the polarization and electromagnetic signatures. Ground-based magnetometers are pegged at their limits. Satellites report micromomentum shifts, and observatories across the globe are scrambling to decode the signal. Every instrument confirms the same reality. This is active, deliberate, and controlled. The implications of this are staggering. If the beam is indeed probing Earth's internal structure, it may be mapping magnetic anomalies, stress points in the crust, or other geophysical data that we cannot even access with our current technology. If the beam is communication, then the medium is as advanced as the technology itself, using planetary-scale physics to transmit information. Either scenario forces us to reconsider what we thought was possible in both engineering and interstellar interaction. For ordinary observers looking at the sky, it's a spectacle of unimaginable beauty. Curtains of neon green dancing across the daylight sky, glowing against the sun, undulating with rhythmic precision. But beneath that beauty lies a demonstration of power and capability that is utterly alien. The energy involved, the precision, and the modulation all suggest an intelligence operating with resources and knowledge far beyond our own. We are at the threshold of understanding something extraordinary. The world has never seen an object that can combine propulsion, energy transmission, data encoding, and planetary-scale interaction into a single, coherent phenomenon. The very laws of physics that govern natural events appear to be at the mercy of this entity's control. What we are witnessing is the first tangible evidence that intelligence can operate in deep space with a level of precision, energy, and influence that challenges everything humanity has achieved. And yet, for all of this, one critical question remains. Why? Why focus on North America? Why target a mid-oceanic rift? Is this a scientific probe, an exploratory mission, a communication test, or something more ominous? The answer is unknown, but what we do know is that this object, 3I Atlas, is active, aware, and intentional. It is using physics we barely understand to interact with our planet in ways that defy natural explanation. As I monitor the live feeds, satellites, magnetometers, and spectrographs, one thing is abundantly clear. This is a turning point. Humanity is observing, in real time, an intelligence demonstrating capabilities that are simultaneously awe-inspiring and terrifying. The Aurora pulses, the beam remains locked, the Earth responds, and we are left to grapple with the realization that we are no longer the sole masters of our environment. This is not science fiction, this is unfolding before our eyes. 3i Atlas is here, it is active. It is sending a message, exerting influence, and demonstrating control in ways that are entirely unprecedented. Every second that passes is another piece of the puzzle. Another clue to the capabilities and intentions of a force operating with mastery over physics that we have only begun to grasp. So, what do we do now? We watch, we measure, and we decode. We attempt to understand an intelligence far beyond our own, using every tool we have. And for you watching this, the sky itself has become a screen. Every pulse, every flash, every modulation carries information that may change our understanding of the universe forever. If you've been watching this unfold, don't look away. Record, observe, question, and share. We are at the beginning of a new era in human understanding. 3i Atlas has arrived, and the implications of its presence will reverberate through science, technology, and perhaps the very foundations of what it means to be human. Stay vigilant, watch the skies, and remember, this isn't just an aurora, this is a message, written across our atmosphere in neon green, and it's just the beginning. If you want to stay updated on the latest developments with 3i Atlas, understand the science behind its beam, and witness history unfolding in real time, make sure to subscribe, hit the notification bell, and share this with anyone who wants to see the future of space exploration revealed today.